All right, for those that came back, thank you for being here again. Okay, so this last part we're going to talk about. There's five basic properties of logarithms here. These work with any log of any base. Okay, um, the first one here is, in my opinion, the most important. 2 through 5, you could have never seen this part of the notes and been okay, but they're they're shortcuts for you. Excuse me. So if you are into shortcuts, go ahead and memorize these. But you do not need these to be successful. As long as you're comfortable transferring between log form and exponential form and vice versa, you can be completely successful. I don't memorize these. Some of them I've seen so long that I just kind of um, I notice them, but I don't sit here and say, oh, I see this, so I know it's going to be equal to 0, right? I still do the transfer to exponential form or the transfer to log form. Okay, so on the blue side, the first one, this one is important. Make sure you guys know that. So if you have log base a of x is equal to log base a of y, two logs are equal and they have the same base, then we know the inside of those logs have to also be equal. Okay, it's kind of like your exponential terms where you have a to the x equals a to the y. If you have the same base, then you know the exponents have to be equal. Same idea here. So how will this be applied? On the right side, if you have an equation that says solve log base 2 of x equals log base 2 of 12, I have two logs of the same base, so I can set the inside equal to each other. X equals 12, solve for x, we're done. Okay, pretty simple. Second one, if you have log base a of 1, or any base, right, and 1 is on the inside, it will always be equal to 0. So for example, if I'm telling you to evaluate log base 3 of 1, our first step on that, okay, is going to be to set this equal to our variable and then convert it to exponential form. So this would be 3 to the x is equal to 1. And remember, anytime you have a base raised to the power of 0, it's going to equal 1. That's the only way that happens, unless your base is a, or unless your base is 1. But any other base, you have to raise it to the 0 power in order to get an output of 1. So that's why that rule is going to always be true. All right, next one. If you have log base a of a, it will always equal 1. So if you have the same base and the same inside, it will always be equal to 1. So for example, if I say evaluate log base 6 of 6, okay, let's set that equal to our variable. Let's convert it to exponential form. So 6 to the x is equal to 6. I like to always put an exponent on there. So 6 to the first. I have the same base. Therefore, I know the exponents have to be equal. So that evaluates to equal 1. Okay. Next, it looks kind of similar, except now I have this exponent here. And that exponent is going to show up again as the value over on the right side. So I'll show you why that's the case. If you have log base a of a to the x, so the same base and the same inside of your log. If the inside has a exponent, that's what the log would be equivalent to. We really did that on the first one, right? This was a to the first, so it was going to be equal to 1. This is a to the x, so it's going to be equal to x. Okay, so let's see this one in action. Again, here's log base 4 of 4 to the second. So I'm plugging in some numbers here. Let's set that equal to x. Let's convert it. So 4 to the x equals this value, 4 to the second. This is why that's going to be true. I have the same bases, so the exponents have to be equal. So that would equal 2. All right. Okay, this next one looks a little goofy. Number 5 is actually an exponential term. It's not a log term. The the exponent has a log in it, but this is a base raised to an exponent. Okay. So if you have the base of your exponential term is the same as the base that's in the exponent, right? So if I have a is equal to log base a of something, it's always going to simplify to be equal to the inside of that log. Okay, so for example, this next one's going to equal 4, right? I have the same base in my exponential and my log. It's going to be equal to 4. I'll show you why. Let's set this equal to our variable. Since this is an exponential term, I need to convert it to log form to solve it. So this would convert as log, drop my 3, log base 3, and then I swap these, right? So log base 3 of x equals my exponent, which is a log form in itself. So I get log base 3 of x equals log base 3 of 4. Log equals log, both with the same base. So the insides have to be equal. So that's going to equal 4, which is what we said it would equal. Okay. So again, I showed you in the example side, I showed you how we can prove that that's always the case by simply converting back and forth from exponential to log form. So some of you are going to be more comfortable just doing that conversion. Some of you are just going to do enough of these problems that you memorize what some of these are equal to. Do what's best for you. Okay. So for 1 through 6 over here, I'm actually not going to use those properties. I'm going to use converting. Let's see, these are all, well, 4 of them are logs, 2 of them are exponentials, right? These 2 are exponentials, but as long as you convert to the other form, you can solve. So number 1, set this to x, convert to log form, 7 to the x is equal to 1. The only way that's true is if my exponent is 0. Number 2, set it equal to x. Drop and swap. So my base here becomes the base of the exponential term, right? And swap these. 11 to the x, square root of 11 to the x equals square root of 11. I'm going to throw an exponent on there of 1. Same base, therefore x has to equal 1. All right, now I have an exponential term. Same thing, set it equal to x. Drop and swap. I'm going to convert this to log form. So log base e of x equals my exponent. Notice log base e on the left side. That's really the same thing as natural log. So I can rewrite the left side as ln x equals ln 8. I have the same log on each side. So the inside x has to equal the inside 8. Would equal 8. Okay, feel free to try these and then you can pause and come back and see the answers. Um, 15 and 5 and 6 are a little tricky because there's more to do other than just a log, right? And now I have 15 times this log. So let's isolate the log real quick. Okay, I'm going to pull that out over here. Natural log of 1. Let's pretend that was the only part of the problem. Okay, well, let's set it equal to 0. And I want to recognize that natural log is really log base e. So log base e of 1 equals 0. Now I'm going to convert, speed that up. What am I doing, Mr. Larson? Come on. Set it equal to x, right? Set it equal to a variable. So natural log of 1, set it equal to x. Change it to log base e of 1 equals x. Now I want to convert e to the x equals 1. Well, x must be 0, right? That's why I was writing 0. So natural log of 1 is equal to 0. So this is really 15 times 0, which is 0. All right. Next one, again, find the log. Whatever that log is equal to, I'm just going to divide it by 6, right? So let's take natural log of e. I'm going to rewrite it as log base e of e. So that's what I want to evaluate. Okay, let's evaluate it. Let's set it equal to x. Let's convert it to exponential form. Remember, it's e to the first, right? So I know that x has to equal 1, right? So natural log of e is equal to 1. So this is really 1 over 6. right? This is really equal to 1 up here, so 1/6. All right. Last 1, 2, 3 at the bottom. These are all going to focus on that first rule of logs up here. So notice that all of these examples, you have the same log on each side. It's just the insides are different. So log base 9 of y equals log base 9 of 16. I know that y has to equal 16. I'm done. I don't have to solve, right? Some of these get a little more complicated, but inside of my log, so 4 minus 3x equals x plus 2. Subtract x from each side. Subtract 4 from each side. And we get x equals 1/2. Excuse me, 1/2. Lastly, I have natural log of x squared plus 4 equals 29. So x squared plus 4 has to equal 29. Subtract 4, square root, and we get x equal to plus minus 5. All right, guys, that's it for part 2. Thanks for tuning in. See ya.